What you don't know can hurt your engine. My name is Mike Brzonek, Associate Publisher and Editor-in-Chief of Diesel Progress Magazine, and on behalf of Cummins Filtration, I'd like to welcome everyone to this interesting and informative event. Fluids are the lifeblood of diesel, natural gas, and gasoline engines, and with today's engines providing higher power density and lower emissions, it's even more important than ever to make the right choices, and that's especially true of engine coolants. While a lot of people still call them water-cooled engines, in truth, there's a lot more technology at work in today's engine coolants. And as you'll see and hear, more than a third of all engine problems start in the cooling system. Today's session will help you learn about the types of engine coolants, what goes into each, and what you need to know to make the right decision to protect your engine investment. Leading our discussion will be an expert in the field, Lauren Lewis, who is Product Development Engineer, Coolants and Chemicals at Cummins Filtration. After Lauren's presentation, there will be time for questions, and the entire presentation will be available on the Diesel Progress website following the session. So with no further ado, here's Lauren Lewis.
Thank you, Mike. Good morning, and thank you for joining us for a discussion of common cooling system challenges and Fleetguard coolant solutions for today's diesel engines. It's an exciting time for us in the Coolants and Chemicals department here at Cummins Filtration, as we currently have the most versatile and extensive coolant lineup in our company's rich history. Cummins Filtration has been formulating engine coolants for over 40 years. Our coolant technology specifically focuses on the needs of heavy-duty engines. We are unique in the coolant industry in that we are the only coolant manufacturer and distributor that is part of an engine company. As part of Cummins Inc., Cummins Filtration engineers are involved firsthand in cooling system issues and lead the industry in knowledge of cooling systems and the evolution of diesel engines. This knowledge allows Cummins Filtration to develop and commercialize coolant technology that addresses the needs of today's engines. We know engine, we know heavy duty, we know coolant. The general function of coolant is pretty simple: to transfer heat from the engine. This is done by removing heat from the engine components, circulating the heat through the cooling system, and dissipating the heat through the radiator. The thermostat allows the cooling system to control the temperature of the coolant. However, as simple as this sounds, coolant technology and maintenance is extremely important to the function of the engine. To give you an idea of just how hard your cooling system works, a typical heavy-duty cooling system will circulate a 16,000-gallon swimming pool worth of coolant every hour. A coolant must protect the whole system in order to properly remove heat from the engine. The coolant interfaces with many different surfaces and is also used to manage the temperature of other engine fluids. To properly transfer heat, the coolant must protect the system components from corrosion, cavitation, and scale. Studies show that more than 40% of engine problems originate in the cooling system. This makes selecting and maintaining your coolant key to protecting your equipment. When selecting a coolant, it can be difficult to determine which product is right for your application. Many customers rely mainly on color, but unfortunately manufacturers do not use standard color conventions, and coolants of the same color are not always similar. One manufacturer's green coolant is probably not the same as another manufacturer's green coolant. A knowledge of how coolants are classified can be helpful in determining the difference between products and understanding which product is right for you. Typically, coolants are classified in two different ways. They can be classified in terms of the coolant's performance and can also be classified according to coolant type. Coolant performance is generally in reference to the performance of the coolant when tested according to industry or OEM standards. This testing may also be related to the compatibility of a coolant with all the materials in the cooling system. Performance specifications use standard test methods to evaluate the performance of a coolant. ASTM is the American Society for Testing and Materials. This group has developed tests that are commonly used in the coolant industry. The ones you'll hear about most often are ASTM D3306 and ASTM D6210. ASTM D3306 contains several tests that define requirements for light-duty coolant. The specification measures key physical properties of the coolant, like freeze point and boiling point. D3306 also contains performance requirements that evaluate the corrosion protection of a coolant under many different conditions and also test for protection against water pump cavitation. ASTM D6210 includes all of the testing required for D3306, as well as additional testing that evaluates the performance of the coolant for heavy-duty applications. The primary additional requirements test the ability of the coolant to protect against cavitation of wet liners, as well as the ability to protect hot surfaces against scale. When looking for a heavy-duty coolant, it is extremely important to look for an indication that the coolant meets the 6210 standard. Passing all these industry tests indicates that the coolant meets minimum performance requirements. In addition to these ASTM standards, many OEMs, like Cummins, will require additional testing. The OEM requirements provide performance or compatibility information that the OEM feels is important to the protection of their equipment. Cummins coolant specification, for instance, includes an elastomer compatibility component that isn't included in either of the ASTM standards. The OEM spec will typically be the most stringent of the specifications and will include all of the requirements found in the ASTM standards. Coolants can also be classified based on product type. Typically, type classifications are just generic terms that are related to the base type and additives used in the coolant. Although these terms can be very useful in general classification of coolants, coolants within each type will vary some in composition and performance. When discussing coolant types, it's important to understand the components of a coolant. Coolants are made up of three basic components: water, a base, and additives. Type classifications are made with respect to the base type as well as the additive type. Almost all commercially available coolants use water as a component because it transfers heat so well. There are three different base types that are commercially used in engine coolants. These are EG, TG, and glycerin. You're probably most familiar with EG, or ethylene glycol-based coolants, as they are by far the most common and account for around 90% of coolants sold in North America. EG-based coolants are the most common because of their ability to be used in almost all climates. The drawback of EG is that it's toxic if ingested. PG, or propylene glycol coolants, are typically used by customers who are looking for a non-toxic alternative. PG is not as widely used as EG because it's more expensive and cannot be used in Arctic climates. Glycerin is similar to PG in that it is also non-toxic and is only suitable for use in moderate climates. Glycerin-based coolants make up the smallest portion of the U.S. market. You may wonder why the base is important, especially since water is so efficient at transferring heat. By mixing water with a base, the freeze point is lowered and the boiling point is raised. This allows the coolant to transfer heat in more extreme temperature conditions than water can handle alone. The boiling point of the coolant is especially important in applications using EGR, or exhaust gas recirculation. The EGR cooler puts off high levels of heat that may cause boiling of the coolant if enough base is not present. When coolant boils, it forms a layer of steam next to the hot surface and prevents heat from being transferred from the component. This can result in fatigue or failure of the component. Most OEMs require that the base be present in a concentration between 40 and 60%. If you need to check this in the field, you can use a refractometer. Coolants are also classified based on additive content. Additives are the chemicals added to the product to protect from corrosion, cavitation, and scale. There are 3 different generic terms that you'll hear to describe additive chemistry. These are conventional, hybrid, and OAT, or organic additive technology. Each of these coolant types will have a base. By that I mean you'll see conventional EG products, hybrid EG products, and OAT EG products. Conventional coolants use the oldest additive technology and typically have the lowest initial cost, but they also have the shortest service interval and the shortest overall life. Over the life of the vehicle, conventional coolants will have the highest total cost of ownership and can end up costing more than 10 times compared to a premium extended life coolant. Hybrid coolants mix the older additive technology with newer organic additive technology to provide extended service intervals at a moderate initial investment. Hybrid coolants typically have a longer service life and service interval than conventional coolants, but typically have more maintenance requirements than an OAT-type coolant. OAT, or organic additive technology coolants, use the newest type of additive chemistry. This type of chemistry will typically have the fewest maintenance requirements. OAT coolants are also more tolerant of system contamination and are typically the preferred coolant type of OEMs. When choosing and maintaining your coolant, be sure to look at the service interval and maintenance interval of the product. Typically, conventional coolants have less than half the life of hybrid and OAT coolants and require more frequent maintenance. Also, note that service intervals vary within each group. Commercial heavy-duty OAT coolants have coolant lives that range from 600,000 to 1,000,000 miles, depending on the manufacturer. ES Complete OAT is one of the few products in the industry that can claim a 1,000,000 mile life. Using a 1,000,000 mile coolant over a 600,000 mile coolant can save owners up to 35% in total cost. Selecting the correct coolant and properly maintaining the system is important to preventing costly failures. We'll go through some of the most common failures that occur in the field and discuss the best way to protect your equipment from these failures. The first potential failure is liner pitting. Liner pitting is specific to the heavy-duty industry. If not properly formulated or maintained, coolants may not be capable of protecting the liner surface against cavitation. A lack of protection will result in small pits forming on the surface of the liner. Typically, this pitting will be in the thrust, anti-thrust directions. In some cases, this results in pits that perforate all the way through the liner and allow coolant and oil to mix. This type of failure requires the engine to be rebuilt. To protect your equipment, you should first ensure that any coolant used for heavy-duty applications meets ASTM D6210. As I mentioned earlier, this spec contains a test that evaluates the ability of the coolant to effectively protect liners. This test is an engine test that measures the amount of pitting, with a lower number being better. Most coolants will list the standards that the product meets on the coolant packaging or in a product brochure. So be sure to look for an indication that the product meets ASTM D6210 before using on a heavy-duty application. It is also important to know what the maintenance requirements are for your product. Typically, conventional and hybrid coolants need to be tested and serviced to maintain liner protection throughout the life of the coolant. Some oat coolants will also require periodic maintenance. It's also important to make sure that units are topped up with proper coolant. If you dilute with water or an improper coolant, you can cause the liner pitting protection to be compromised. If additives become unstable, they can cause issues in the cooling system and leave your system unprotected against corrosion. There are a number of reasons that this may occur. These include contamination, over-addition of SCAs, or supplemental coolant additives, and poor formulation. Some additives will collect in the cool areas of the engine when instability occurs and impede heat transfer. On the right, you'll see a cross-section of a radiator with plugged tubes due to overtreatment with SCAs. To protect from additive dropout, it's important to make sure the water used for mixing is of good quality. Some tap water will meet the requirements, but most will not. Hard water can react with additives, causing them to become insoluble. When this occurs, scale will form on hot surfaces. The picture on this slide is an example of scale formation on a heating element. When adding SCAs or extenders, only add the recommended amount. It may be tempting to add extra to the system. However, in the case of coolant additives, more is not always better. If the additive concentration gets too high, the coolant will not be able to hold all of the additives in solution. Oat-type coolants are typically more resistant to system contamination and do not require the addition of SCAs or extenders as frequently as conventional and hybrid products. Some oat products, like ES Complete Oat, do not require the addition of any SCAs or extenders when properly maintained. Another common failure mode that can be related to additive instability are deposits on water pump face seals or in weep holes. Deposits can come from additive dropout or from particulate in the system. Some of this particulate may be present in the engine from the manufacturing process. This can include core sand, rust, and other contaminants. To protect your water pump, make sure to choose the proper coolant and avoid over-addition of SCAs and the use of hard water. In some cases, you may not be able to avoid contamination in the system. There will be some contamination from the manufacturing process that will be present in a brand new engine. Using a water filter will help capture particulate before it deposits onto face seals and causes leakage. As engines and cooling systems evolve, more and more aluminum is used in the cooling systems for heavy-duty engines. The use of aluminum radiators and oil coolers has become common in the heavy-duty industry. In addition to this, the preferred method of manufacturing aluminum radiators uses a process that can introduce contamination into the system that actually causes corrosion. Residual brazing compound coats the surfaces of the radiator as seen in the picture on the left. This residual compound will dissolve into the coolant, introducing contaminants. When exposed to large surface areas of aluminum and simultaneously exposed to contamination, it can be difficult for some coolants to properly protect the system. Some of the additives in conventional and hybrid technologies become less stable under these conditions, and are unable to properly protect all of the aluminum surfaces. When corrosion begins to occur, the aluminum is weakened and is prone to suffer from stress fractures, as seen in the picture on the right. Since the contamination is contained in new radiators, it can be difficult for users to control the amount of contamination in their system. Oak coolants are typically more robust to this type of contamination and provide better protection under these conditions. Note or nitrided oat, hybrid, and conventional products tend to be less robust to flux contamination and are more likely to be compromised in this environment. In severe cases, new systems may need to be flushed after a few hours of use to reduce the amount of contamination in the system. Some additives used in commercially available coolant products have a negative effect on gasket and hose materials that are used in cooling systems. These additives will cause silicone gaskets and hoses to degrade and become brittle. The material will also shrink in size. This change in material properties affects the ability of the gaskets and hoses to seal properly and will result in leakage. Depending on the location of the leakage, this issue can have varying levels of severity. One of the more severe failures that we see is in head gasket seals. This is a picture of a head gasket that has been affected by incompatible coolant additives. The silicone seal material around the head gasket ports has delaminated due to shrinkage and material deterioration. This causes the seal to become ineffective and results in leakage of exhaust gas into the coolant and leakage of coolant into the combustion chamber. Exhaust gas will quickly deteriorate the coolant and will actually promote corrosion of other components in the cooling system. To protect against seal and hose failures, be sure to select a product that is approved by your equipment and engine OEM. In response to failures in the field, most OEMs require compatibility testing to ensure that the coolant is compatible with the materials used in their engines. The chemical name for the additive that is known to be incompatible with silicone seals is 2-ethylhexanoic acid. To be certain that your equipment is protected, you can look for this additive name in the ingredients on the coolant bottle or on the coolant material safety data sheet. So let's take a quick recap of what we've looked at today and how the right coolant technology can prevent many of these problems. First of all, pay attention to coolant classification when picking the right coolant for your needs. Don't simply choose a product based on color, as it's not a foolproof way of picking the right product. When selecting a coolant, remember that a less expensive coolant may require more maintenance and cost more in the long run. Even the difference between a 1,000,000-mile oat and a 600,000-mile oat can represent up to 35% in total cost savings. Choosing the proper coolant can protect your engine and your wallet. Make sure the coolant is approved by the equipment and OEM to ensure that the coolant is compatible. Many products on the market, especially oat products, are not compatible with all seals and hoses used in cooling systems. When looking for a heavy-duty coolant, it's important to look for the indication that the coolant meets the 6210 standard. This will ensure that your equipment is protected from liner pitting. And finally, if your application is prone to contamination, an oat coolant may be the best selection for your equipment. All of Cummins Filtration's coolant products are tested for heavy-duty industry standards, as well as Cummins coolant standards. Our products are used in the validation testing of Cummins engines. We offer a full product line that spans from conventional technology to the newest organic additive technology to meet the needs of all of our customers. Cummins recommends our products in engineering standards, fluids bulletins, and in engine manuals. Each of our products is Cummins tested and Cummins approved. For more information on coolant products, cooling systems, and cooling system maintenance, visit CumminsFiltration.com. Product literature and training is available. We also have videos related to coolant and coolant system maintenance available on YouTube. And with that, I'll open the line up to questions. Mike, do you want to?
Sure thing. First of all, thank you, Lauren, for that informative presentation. We'll now open it up to questions, and we'll ask that the audience please send us your questions through the chat function on the screen, and we'll try to get to as many as possible in the time we have left. We do have one that was sent to us during the talk asking, why should I buy premixed coolant when I have plenty of water in my shop?
So this is kind of a common question for customers. Interestingly enough, you can drink water that your engine can't tolerate. So when you're pre-mixing coolant, it's really important to make sure that the water that's being used is appropriate for coolant. Using a pre-mixed coolant causes you not to have to worry about that. It also makes sure that the coolant in the base is in the correct proportion, so you don't have to worry about your maintenance employees or yourself mixing the coolant in the proper proportions.
Okay, another question from the audience asks, can I mix different colors of coolant?
So when we talk about mixing coolant, most producers use kind of a same bucket of chemicals. So there are a lot of different chemicals that are used, but producers will use them in different combinations and in different concentrations to make a final product. So if you mix two products, usually the chemicals are going to be compatible. You're not going to get a crazy negative chemical reaction in your cooling system. However, you do need to remember that when you mix coolant, you may be affecting the service interval of your coolant or the level of additive protection if you're mixing coolants that are two different types. So best practice is not to mix, but again, if you do mix, you're not going to get an immediate negative reaction.
Okay, another one, what's the difference between ethylene glycol and propylene glycol?
Okay. The main differences between ethylene glycol and propylene glycol has to do with the toxicity of the products and where they can be used. So EG is really the most common because it can be used everywhere. The drawback of EG is that it's toxic to humans and animals if ingested. PG, on the other hand, is not toxic, but is limited to use in moderate climates.
Okay, we have one coming in asking about specifically slide 24, the last bullet, asking, is that good or bad?
So that would be bad. So if there's 2-ethylhexanoic acid in the coolant, that means that you're risking an incompatibility with your elastomers. So if you have silicone seals or hoses and you have this particular component in your coolant, there's a high risk that you're going to experience, degradation of those hoses or gaskets and have a leakage.
Okay. Another one coming in, are there also grades or different quality of coolant filters to use, or are they all the same?
So there are different grades of coolant filters. Typically they're all bypass filters, but selecting a good type of filter that fits your application is going to be extremely important. And also to make sure that the coolant filter matches the coolant that you're using. So many suppliers have coolant filters that have chemical in the filter. So it makes it a little bit easier for you to re-inhibit your coolant or refresh the additives in your coolant. And you would want to use those types of filters with conventional or hybrid products. If you're using an oat product, you would want to use a non-chemical type filter.
Okay, another one, did you say oat-type coolant has negative effects on some elastomer components in the engine?
So that's not all oat coolant. There are specific oat coolants that use 2-ethylhexanoic acid that can be incompatible, specifically with silicone elastomers and seals. There are other oat coolants that don't contain that particular additive and are fully compatible with all of your elastomers and seals. For instance, our product, ES Complete Oat, does not contain 2-ethylhexanoic acid, and it passes, all of the OEM required elastomer compatibility tests.
Okay, how frequently should the cooling system be checked to make sure the additive package is still effective, or does that depend on the type of coolant used and the duty cycle of the vehicle or machine?
So that will usually depend on the product, but you should test at least once a year. And, we kind of view this as like an insurance policy for your cooling system. You may test and you may not need to service the coolant at all. But testing can be really helpful in determining if there are any engine conditions or cooling system conditions that require attention, or even maintenance practices that you might not be aware of that are causing issues. And they let you fix those problems before they become, something really severe. So our recommendation is always to test, even if that, doesn't necessarily mean that you need to service. It can be really helpful as a screening tool.
Okay, next one coming in. Are all of the Fleetguard coolant products oat?
No, they're not. So let's go back to this slide. So if you look here, there are 4 different products. FleetCool is a conventional type product. So that's kind of the older additive technology. And then ES Complete and FleetCool AX are hybrids. So they're going to contain some conventional type additives and some oat type additives. And then ES Complete Oat is mainly organic acid technology. So it's going to be more of a full oat, if you will, and what's considered an oat type coolant in the marketplace.
Okay, is conventional coolant green color and oat coolant red color?
Not always. So for our Fleetguard products, that is the case. But if you look at another manufacturer, for instance, green coolants, there are a lot of green coolants in the market that don't meet 6210. So just because it's green doesn't necessarily mean that it's appropriate for heavy duty or that it's comparable to the FleetCool coolant. And then, if you look at oat coolants as well, I know that there are some competitive red coolants that are nitrided oat. So those might not be a good choice if you have a lot of aluminum in the system. So it's, as I said before, sometimes the color can be a little bit misleading. So it's important, to kind of look for some of the other classifications. Does it meet 6210? As well as, what does it say on the bottle? Does it say oat? Does it say fully formulated? Some of those will give you some ideas as to what the product actually is, aside from just looking at the color.
Okay, a question coming in. What is NOAT, N-O-A-T?
So NOAT is nitrided oat. So that would be a coolant it's got a lot of organic additive technology, maybe more than your typical hybrid product, but it also has nitrite in it. And nitrite can be one of the additives that's not a great choice for environments that have a lot of aluminum, especially aluminum heat exchangers. So it's an oat type coolant that has a kind of one of the older conventional type additives in it.
Okay. Are there specific coolant types that are better suited to specific applications?
Yes. So, as we've talked about kind of the cooling systems evolving over time, if you've got an application that uses a lot of aluminum, especially aluminum heat exchangers, then an oat, not to be confused with an oat coolant, would be kind of the best choice for that application.
Okay. Referring to the comment on haute coolants, are they better, does it mean flux contamination or contamination in general are they better at, such as dirt, metals, or sand from casting?
So it would refer to flux contamination as well as contamination from hard water.
Okay. Because so many people run mixed fleets, what are the modern coolants such as the ES Complete and the ES Complete Oat and Fleet Cool EX, are they fully backwards compatible with older engines in the field?
Yes, so our products would be backwards compatible with older engines in the field. I think that kind of where this question originates from is some OEMs have changed seals in newer engines to be more compatible with the 2EH or 2-ethylhexanoic acid coolant. But since our oat coolant does not use that additive, it would be compatible with all coolants, the newer engines and the older engines.
Okay, we're coming about to the end of our time, and I'd like to thank Lauren for her excellent presentation, and also thanks to all of our attendees. To those who would like more information or have more specific questions, we did have a lot of questions and we can't get to them all, you can get in touch with Lauren, whose email was included in the slides. All of the slides and the complete audio portion of today's presentation will be available shortly at the Diesel Progress website at www.dieselpub.com. Thanks for joining us today, and from all of us at Diesel Progress and Cummins Filtration, have a pleasant rest of your day.